All right, Chapter 5, Question 105. When hydrochloric acid is poured over potassium sulfide, 42.9 milliliters of hydrogen sulfide gas. So, volume of hydrogen sulfide gas is 42.9 milliliters. 9 milliliters. Produced at a pressure of 752 torr. 752 torr. And 25.8 degrees Celsius. Okay, write an equation for the gas evolution reaction and determine how much potassium sulfide in grams reacted. All right, let's do exactly that. So we poured hydrochloric acid, right? Hydrochloric acid, and this was now these things are mattering. So this was liquid, and that was over potassium sulfide. This is an aqueous. This gave us hydrogen sulfide gas and potassium chloride, which is going to be aqueous. That'll be a salt. Okay, let's balance this thing. So, where can we start? We have 2 potassiums. Right, means that now I need 2 of those. Was that it? Did that do it? Let's see, 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines, 2 potassium, 2 potassium, 1 sulfur, 1 sulfur. Hey, look at that. All right, so now that that's done, so our first step now is going to be to find the moles of this of the H2S gas with the ideal gas law, and then after that we'll use stoichiometric ratios to find the moles and the mass of potassium sulfide. All right, so first off though, we're going to find moles of H2S. Okay, so moles of H2S. This is coming out of the ideal gas law, right? Which I'll put over here in small print. We're solving for the N here. So this is going to be equal to pressure times the volume over the ideal gas constant and the temperature. Okay, so we are going to have a couple unit conversions here because they, give you these in all manner of things. We have 752 torr, right? Millimeters of mercury is the same as torr. And we're going to need this in kilopascals, right? So that's going to be 100 kilopascals. And 750.06 milliliters of mercury. Okay, so that does that. There's the pressure taken care of. That's going to give us what we want. Next we have the volume. Volume is in milliliters. That's an easy fix. 2.9 milliliters times. Write what you want up top. What you don't write on what you don't want on the bottom. All right, that's going to give us that. Sorry, and that is going to give us. So we're going to have kilopascal liters. All right. Ideal gas constant, 8.314 joules per mole Kelvin. And we're multiplying that by 25.8 degrees Celsius. We're converting this to Kelvin, so 273.15 Kelvin. All right. So this is going to give us kilopascal liters. That's going to cancel that out. Kilopascal liter is equal to a joule, so that is going to give us moles. Perfect. All right. So this whole disaster, you can check this. So you can check this with the calculator, but I have this done ahead of time. Is 1.73 times 10 to the negative 2 moles. Okay, so now here you see the like hydrogen sulfide, potassium sulfide. This is a 1-to-1 stoichiometry. So that means that this amount of moles is the same for each species. So we can go straight to the mass. So I'm just going to hide the mass in this bottom corner here. All right, so the mass of potassium sulfide equals moles times the formula weight. All right, so that is 1.73 times 10 to the negative 2 moles times the formula weight of potassium sulfide is 110, 10.27 grams per mole. All right, and that gives us a total mass of 0.191 grams. There you have it.